Hello students, in previous video we have discussed about stick diagram and layout diagram, how to draw stick diagram and layout diagram for NMOS circuits and CMOS circuits. Today we will discuss about the basic circuit concepts. In the basic circuit concept we can see we know that there are various layers in the CMOS as well as in NMOS. Okay, the different layers are N-type layer, P-type layer, poly layer, metal layer. So MOS layers have some different resistance and capacitance. So we have to find out MOS layer resistive characteristic and capacitive characteristic. Okay, we have to evaluate the effect of wiring input and output capacitances, that is seat resistance and standard unit capacitances. Okay, so standard unit capacitance is used to find out seat capacitance. Okay, also we know that the RC time constant, that is resistance and capacitance. For the resistance, delay resistance and capacitance, so delay will depend upon this R and C components. Hence we need to find out what should be the resistance and what should be the capacitance. So for this purpose we need to find out the resistance. Okay, so in this case you will get the first concept, it is the seat resistance. Okay, seat resistance. Okay, now you can see here one layer, that this layer it is, so you can say it is a silicon layer, and that silicon layer it will have length is L, width W, its thickness is a T, and we have to find out the resistance between terminal A and B, or resistance between point A and point B. Okay, to find resistance between point A and B, we know that the basic equation for the resistance RAB is equal to rho into length divided by cross section area, in general rho L by A. Okay, so rho is the specific resistivity of this material, L is the length of the seat, thickness or cross section area, this is the cross section area, and this cross section area is nothing but the thickness multiplied by width, so therefore T into width. Okay, now if we see here, that is rho by T, if I assume, is equal to RS. Okay, so RAB is equal to RS into L by W, length as to width. Okay, now this RS is called as a seat resistance. RS is called as a seat resistance, and it is equal to rho by T. Okay, and it is a constant, rho by T, and it is a constant, and it is called as a seat resistance. From the above equation, seat resistance can be defined as the resistance of a channel whose length and width are equal. Okay, so in this equation you can say length and width is equal, then seat resistance RS is equal to rho by T. Okay, so RS, seat resistance, is completely independent of area. Seat resistance RS is completely independent of area. For example, 1 micrometer by 1 micrometer slab if you take, okay, that material have exactly same seat resistance or same resistance as that of 1 centimeter by 1 centimeter slab. The same material with the same thickness, same resistance you will get when it will have same thickness. Okay, if the seat resistance having, suppose this is 1 centimeter by 1 centimeter, and if we take 1 micrometer by 1 micrometer, it will have same seat resistance if thickness is same. Okay, So seat resistance is completely independent upon area. Okay, it will depend upon the rho by T. So this is about the seat resistance. Now we will find out seat resistance of various layers as well as transistor. Okay, seat resistance of a diffusion layer. Seat resistance of diffusion layer, it is to find out very difficult, but it will depend upon the doping concentration. Okay, so diffusion layer never be used for the signal flow. So diffusion layer we can use it for whenever diffusion layer and polysilicon layer crosses, it will form transistor. Okay, then hence we can find the channel resistance. Okay, so channel resistance, it can be calculated depend upon the type of transistor. So there are various types of n-type transistor, p-type transistor. In the n-type transistor also there you will get the depletion mode transistor and enhancement mode transistor. Let us see here the n-type transistors. So n-type transistor, either it may be depletion mode transistor or may be enhancement mode transistor. So it will resistance, it will depend upon length and width ratio. Okay, now we will see how to find channel resistance of NMOS transistor. So for n-type transistor, so you can see, so this is horizontally, that is this forward slant lines are there. So this is a diffusion and backward lines are there. Okay, so this is poly layer. Okay, so width of the diffusion layer is 2 lambda, width of the poly layer it is 2 lambda, and hence so this is 2 lambda, this is also 2 lambda. So feature size or length and width, length as to width ratio of this channel is 2 lambda by 2 lambda is nothing but the 1:1. Its ratio is 1:1. Okay, so how to find the channel resistance? To find out channel resistance, so we should know what is the unit square of that channel. Okay, channel area is equal to how many unit squares, that is we have to find out. So that is 1 unit square here it is. So resistance for NMOS transistor also it will depend upon this which type of technology it is. So there are different technologies. So you know that there are different technology, that is 5 micrometer thickness technology, 2 micrometer thickness technology, 1.2 micrometer thickness technology. Depending upon this thickness layer, so there are different technologies. Now, so if we consider it is for 5 micrometer technology, that is if resistance, that thickness or diffusion layer, it will have 5 micrometer technology. So then, so its seat resistance, okay, it will be given by the manufacturer, and in your book it is a prescribed book, it is given that is 5 micrometer technology, seat resistance will be 10⁴ ohm per square. Okay, so now resistance offered by n-type transistor is equal to number of squares into seat resistance. Okay, so therefore 1 square into 10⁴ ohm per square, square gets cancelled, so resistance is equal to 10⁴ ohm, means 10 kilo ohm is the channel resistance offered between drain to source. Okay, channel is offered between drain to source, so this is length and this is width. Okay, also we can find the channel resistance by using this equation. Channel resistance is find out by using R is equal to Z into RS, where RS is the seat resistance for n-type transistor for 5 micrometer technology in this example. Okay, and Z is equal to length as to width ratio. Okay, so therefore Z is equal to length as to width ratio, that is 1 square, and seat resistance it is equal to 10 raised to 4 ohm per square. Okay, therefore 10 raised to 4 ohm is the channel resistance offered between drain to source. Okay, how to find out n-type depletion mode transistor in 5 micrometer technology? Set resistance of the resistance offered by the transistor in 5 micrometer technology. So both are the n-type transistors, and resistance it will depend upon the length and as to width ratio. Okay, either it may be depletion mode transistor or may be enhancement mode transistor. Okay, so you know that this is the equation, that is R is equal to Z into RS. Now here it is the depletion mode transistor, and depletion mode transistor it will have, so we have seen that is what is the depletion mode transistor, and this length of the transistor is 8 lambda, width of the transistor is 2 lambda. So therefore length as to width it is 8 lambda divided by 8 lambda and 2 lambda, so that is equal to 4 as to 1. So therefore Z is equal to L by W is equal to 4 as to 1. So there are 4 squares. So you can see this is 2 lambda, this is 2 lambda, this is 1 square, this is second square, this is third square, and this is 4 square. So this is 4 square. So Z is the number of squares. So therefore 4 square, and RS is equal to 10 raised to 4 ohm per square. So therefore 40 kilo ohm is the seat resistance. 40 kilo ohm is the resistance offered by this channel. Now take one more example, that is where length as to width ratio is different. Here you can see here. So length, either this may be drain or this may be source. So therefore this is the length, it is equal to 2 lambda, and what is the width? Width is equal to, this is 2 lambda and this is 4 lambda, total 4 lambda. So length as to width ratio is equal to lambda as to 4 lambda, that is 1 as to 2 you will get. It is a 4 or half it is. Okay, so therefore resistance offered by this channel is equal to R into Z. R is equal to Z into RS. Okay, Z is nothing but length as to width ratio is half square. So half square into 10 raised to 4 ohm per square. Square gets cancelled, and you will get the 5 kilo ohm is the channel resistance. I think you will get the idea how to find out the channel resistance. Now we will go to find out the how to find out the resistance offered by an inverter. Now we will see how to find out the resistance offered by inverter. So you know that there are two types of inverters we have discussed, that is NMOS inverter and CMOS inverter. First we will see the NMOS inverter. In the NMOS inverter you will have, this is one pull-up transistor and one pull-down transistor. This pull-up transistor, it is a n-type transistor, depletion mode, n-type depletion mode transistor, and this is pull-down transistor, it is a enhancement mode transistor. But resistance will depend upon the n-type transistor. For n-type transistor, and it will depend upon the length as to width ratio. So length as to width ratio, it is a 4 as to 1 for pull-up transistor, and for pull-down transistor length as to width ratio, it is a 1 as to 1. So Z pull-up, ZPU means Z pull-up, it is length as to width ratio of pull-up transistor, that is L by W is 4. Okay, so R on state resistance of this pull-up transistor, it is Z into RS, it is same. So therefore 4 into 10 raised to 4 into 10 raised to 4 is equal to 40 kilo ohm. This is the seat resistance of pull-up transistor. What is the seat resistance of the pull-down transistor? So seat resistance of the pull-down transistor, it is again length as to width ratio, Z into RS, length as to width ratio Z into RS. So that is equal to, length as to width ratio is 1, and 1 into 10 raised to 4 is nothing but the 10 kilo ohm. So pull-up to pull-down ratio, it is ZPU divided by Z pull-down, it is 4 as to 1. Okay, So static resistance or static on-state resistance of the NMOS inverter, that is the resistance between VDD to VSS, resistance offered between the VDD to VSS. Okay, and this is called as calculated by the resistance between the VDD to VSS is equal to 40 kilo ohm resistance of pull-up transistor and resistance of pull-down transistor, it is 10 kilo ohm, means it is a 50 kilo ohm. Okay, static resistance of inverter, it is a 50 kilo ohm. Okay, this is about the NMOS inverter. Now we will see about the resistance offered by the CMOS inverter. So you know that the CMOS inverter, it will have one p-type transistor and one n-type transistor. Gate of the p-type transistor and n-type transistors are connected together to for input, and output is connected here, two drains are connected here. Okay, so Z pull up and Z pull down we have to find out. Z pull up, so these two transistors, it will have same length as to width ratio 1:1, and this is also same length as to width ratio 1:1. Okay, now Z pull up is equal to 1, that is for p-type transistor. Seat resistance for p-type transistor in 5 micrometer technology, it is given in book, it is 25 kilo ohm per square, 25 kilo ohm per square. Or you should know that resistance offered by the p-type transistor and resistance offered by holes and resistance offered by electrons, it is a 2.5 times more. So this is about the 10 kilo ohm. Resistance offered by the n-type transistor, it is 10 kilo ohm, and resistance offered by the p-type transistor, it is a 25 kilo ohm. Okay, now you will get the, so this is about the 25 kilo ohm. Okay, now resistance offered by the pull-up transistor, it is Z into RS, it is equal to 1 square, that is length as to width ratio, into 25 kilo ohm per square. Square gets cancelled, and resistance offered by the p-type transistor, it is a 25 kilo ohm, and resistance offered by the pull-down transistor, it is n-type transistor, and length as to width ratio, it is 1. So therefore RS is equal to 10 kilo ohm, or nothing but 10 to 4 ohm per square. So square get cancelled, and you will get the 10 kilo ohm. Okay, so RS is equal to 10 to 4 for pull-up transistor. So this resistance offered by the pull-down transistor, that is n-type transistor, it is N into RS, it is equal to 1 into 10 to 4 into ohm per square. This square and square get cancelled, and so total you will get the 10 kilo ohm. So you know that we can offer here the input, it is equal to either 1 or 0. So no one transistors, there is no condition, that is both two transistors are on at a time, and hence there is no static resistance, from VDD to VSS. Okay, so in case of n-type transistor or NMOS inverter, there is a static resistance from VDD to VSS, but here there is no such a resistance, because no one transistor will be on at a time. Either this will be in high impedance state or this will be in high impedance state, and one transistor will be on at a time. Okay, so then next, resistance of the polysilicon layer or resistance of silicides. So we will see about the what is the resistance of the polysilicon. So you can see the resistance of the polysilicon in the given in the table, that is in the prescribed book, that is polysilicon layer 5 for 5 micrometer technology, it is varying between the 50 to 100 ohm, and it is a too large. And if you use a polysilicon layer such a layer, then it offers very high resistance and delay will be more. You know that the delay is equal to R into C, RC time constant. If resistance is more, then delay will be more, and hence polysilicon is not used for the carrying directly polysilicon. Then how to minimize the polysilicon layer? Resistance of the polysilicon layer. Resistance of the polysilicon layer is minimized by using silicide. What is the silicides? Silicides are the alloy of polysilicon and metal. Okay, metal is deposited on the poly layer and then it is sintered or sintering. Okay, so this type of layer or this type is called as silicides. Okay, and hence so by using this its resistance is decreased, and see the resistance is decreased up to 2 to 4 ohm, and hence silicides are used for polysilicons. Okay, so this is about the how to calculate the resistance of the n-type layer, p-type layer. Okay, resistance of the transistors, what is the seat resistance we have discussed here. Okay, so now for homework you find the on-state resistance. Okay, first example, it is a find on-state resistance of 8:1 NMOS inverter. So into this pull-up transistor it is 8:1 and pull-down transistor it is 1:1. Take one more example, that is find on-state resistance of NMOS inverter having so you can find out only one example. Okay, today we'll stop here.